In this video, we are discussing about introduction of stack. So first of all, what is a stack? Stack is one of the data type. So what type of data type? It is the user defined data types. Because of we are already learned primary data types. What are the primary data types? Int, float, char, double. These are the primary data types. But the stack is user defined data type, and it is also called as abstract data type. Stack is also called as abstract data type. Abstract data type. Stack is a abstract data type. Why? Because the stack can follow not a single statement of the condition. It can follow the number of conditions. What are the conditions? Behavior of the stack, principle of the stacks, operations of the stacks. So these are all things we are going to the abstraction of the stack. So that's why abstract data type. Normal data type is simply one statement, that is one condition. For example, I take the int. Int is only, it can store the integer value. Just one line statement, it is satisfied. But stack is a not single line statement. It is a number of conditions, things it will be followed. So that's why stack is abstract data type. Okay. So then definition of the stack. What is a stack? Stack is a linear data structure in which we are performing deletion as well as insertion at only one end. That end is called as top. That end is called as top. So based on this definition, draw the diagram. Simple. This is push. This is pop. Push pop. Based on the definition, both operations. What are the both operation? Insertion as well as deletion. So both are performing at one end. That end is called as, this is the top end. So that is the followed by stack. So that is the condition of the stack. Where we are performing insertion as well as deletion, and that is only single end. That end is called as top. Next, what are the principle followed by the stack? The stack principle is LIFO. LIFO stands for last in, first out. This is the actually last in, first out. Insertion, it is the last insertion performing B. That B is ready to deletion of the stack. So actually B is the last insertion of the my stack. That element is ready to the pop operation of the my stack. So both are performing at one end only. So that is the principle of the stack, last in, first out. Next, what are the operations performing the stack? So stack can following the 5 operations. 5 operations. So what are the 5 operations? The first one is push. First one is push. In that push operation, we are insert an element into the our stack. At the time we are applying the push operation. Next, second one, pop operation. So in this operation, we are removing an element of your stack. So at that time we are applying to the pop operation. So next, third operation is we are finding the top of the element in that stack. At the time we are applying the top or peak function. So that is the third function. What is the third function? If some elements are there, some elements are available in our stack. At that time we are finding the what element is available in our stack. At that time we are applying to the pop operation or top operation or peak operation. So it will be reflected to the which element is available top of the our stack. That element will be displaying to the output of the our stack. So next, fourth one is full. That fourth operation we are performing is full. When our stack is full, actually our stack size is some size is there. So at that time, at that much of elements will be accepted. If you enter more than the size, at that time stack is full. So next, fifth is empty. When we are using this type of function, if your already stack is empty, so at that time we are try to removing an element at that stack is displaying the stack is already empty. So at that time, at that situations, we are applying to the is empty operation. So these five are the operations of your stack. So totally another one operation is there. That operation is sixth one, size. This special operation, this is the size is the special operation. Actually we are finding the how many elements are available in our stack. At that time we are using this function. This is the size. Okay, so next, conditions of the stack. Conditions of the stack. That means a stack can follow the conditions. So majorly two conditions. The two conditions are, first one is overflow, second one underflow. Overflow, underflow. Underflow means already your stack is empty. Now user can try to remove an element already empty stack. At that time underflow will be reflected. So that is one of the operation condition of the stack. And next, overflow. When it is occur, already stack size we are mentioning some size. So now we are already stack is full, but user can try to insert an element in that already stack full. So at that time stack is overflowing. So these are the conditions, these are the operations, this is the principle, and this is the behavior. So behavior, that means definition. What is the definition? Where we are performing insertion as well as deletion. That is the behavior. Stack behavior. What is the behavior? Where we are inserting, where we are deletion. Both are performing single end only. That is called as stack. So that is the simple introduction of the stack. So now simply implementation of the stack. How to implement a stack with example. With example, implement. Implementation. Now my stack is empty. Now my stack is empty stack. Now I am applying to the one by one stack operations. First operation, push. Now stack is empty, stack dot push. This is the basics. So already stack is empty. Now I am starting to the implementation one by one element in my stack. So stack already I push to the I throwing to the one element. That element is R. Now stack is updated. R will be inserted to the my stack. So in stack R. So now again I push to the element of my stack. So at the time we are writing here stack dot push Z. After pushing to the my stack, then stack will be updated. I draw the updated stack R and Z. This is stack. After completion of the pushing, then will be stack will be updated. So RG elements available in my stack. Now I want to another element throwing or pushing B. Totally continuously I push to the 3 elements. So my stack will be updated. Stack. What are the elements available? R is already available. G is available. New element B inserted. Okay. So 3 operations are same operation. That operation is push. Push is completed. This is one of the operation. Now I am using another stack operation, that is pop. Now how many elements are there? 3 elements available in my stack. So now I am performing another operation, stack dot pop. Stack dot pop. So directly without mentioning a element ID or element name, what are the available top of the element in our stack, that element will be removed automatically without specifying any element ID or name. Without specifying here, only I am just call pop operation, stack dot pop. It means what are the elements are available, but which element is available in top of the our stack, that element will be automatically deleted in that our stack. What is the top of the element? This is the top element. This is the top element. If I am performing the stack.pop, then automatically top element will be removed. Then stack will be updated. I draw the updated stack. What are the available? R, G. B is deleted. So now I want to find the how many elements are available in my stack. So at that time we write a small query. That query is new operation, stack dot size. At that time in that brackets we are mentioning the name of the stack. At the time it will be how many elements are available in that stack, that much of size will be reflected, particularly this statement. Currently how many elements are there in our stack? 2 elements. The 2 is reflecting here. 2 elements. Okay, 2 elements are available. The 2 are R and G. At this time, after completion of your popping operation, after completion of your pop operation, if you want to find top of the element, at the time we are performing another operation. What is that operation? Stack dot top or peak. Which operation? We are finding that which element is available top of the my stack. At that time we are write a top or peak. These 2 functions both are working. So it will be reflected to the in our stack which element is available top. Now present, this is my top element. This is our top element. So that element will be reflecting here. What is that top element here? Z. Okay. Now I am performing another deletion. So at the time query same, pop stack dot pop without specifying a element ID or element name, then automatically G will be removed. This is the top element, so automatically it will be removed. Then our stack is updated. Only R is available. Only R is available. So then finally how many elements are available in our stack? Only single element. So now that elements also we are deleted. Same stack dot pop. Then what happened in the stack? What is the last what is the top of the element in our stack? Now as already only one element is there, so that is top only, so it will be automatically deleted. Then your stack is updated, empty. Stack is empty. So now again we are performing another deletion operation, that is stack dot pop. At that time condition will be automatically reflecting. What is the conditions? Overflowing, underflowing. So in this situation already stack is empty, but user can try to removing an element in our stack. At the time stack underflowing occurring. So this is the simple basics and introduction of the stack operations. And okay, thank you.